In this video, we're going to talk about analyzing a graph. We're going to look at number 35 from the textbook. F of x is equal to 1 over 2 minus e to the negative x. And we're asked to find any extrema, any points of inflection, and any asymptotes in our sketch that we make. So label, okay. So they didn't ask us to find intercepts, but I'll try and find x and y intercepts too, since we normally label those on a graph. So, all right, first is no x-intercepts. My y-intercept will be at f of 0. So 1 over 2 minus e to the 0. So 1 over 2 minus 1 is 1 over 1 is 1. So that gives me the 0.01 on the graph. Let's find my first derivative. I'm going to write this as 2 minus e to the negative x to the negative first power. So I don't have to use the quotient rule here. This will be a negative 2 minus e to the negative x raised to the negative second power times the derivative with respect to x of 2 minus e to the negative x prime, negative 2 minus e to the negative x negative second times 0 plus e to the negative x. So this is going to be a negative e to the negative x in the numerator and a 2 minus e to the negative x squared in the denominator, like that. When I find my second derivative, my u is equal to a negative e to the negative x, and my v is a 2 minus e to the negative x quantity squared. My u prime is a e to the negative x. My v prime is 2 times 2 minus e to the negative x to the first times the derivative of the inside is e to the negative x. So v prime is 2e to the negative x times 2 minus e to the negative x. And that means v prime is, let's just leave it like that. I'll see if I need to expand it in a little bit. So u prime v minus v prime u all over v squared. So f double prime of x will have a e to the negative x times 2 minus e to the negative x will come out. And I'll be left with 2 minus e to the negative x minus plus 2e to the negative x. That came out, and that came out, leaving that negative 1, which changed the sign, over 2e to the negative x to the fourth. This comes down as a minus 1 down there, and that makes this f double prime of x is e to the negative x times 2 minus e to the negative x plus 2e to the negative x is 2 plus e to the negative x over 2 minus e to the negative x raised to the third. All right, so now we're interested in extreme values, which would be from zeros of the first derivative, well, e to the negative x looks like this and is never going to equal to 0. 2 minus e to the x is going to happen at is going to have a 0 at negative ln of 2. So, but that is where there is a vertical asymptote, so that's not a critical number. So there are no local minima or maxima to answer the first question. For us to label, let's look for a point of inflection should it exist. So e to the negative x is never going to be equal to 0, but maybe 2 plus e to the negative x might equal to 0. That would mean that e to the negative x is equal to negative 2. Well, that can't happen. I just showed you the graph, and that graph approaches 0 from the top. It never becomes negative. So that doesn't happen. And the denominator is, again, not changing. So there's no points of inflection here for this problem. So there's nothing for us to label other than for us to find our asymptotes, which we know we have a vertical asymptote. We've been talking about it here a little bit at x equals negative ln of 2 or ln of 1/2 if you want to write it that way. And we have horizontal asymptotes. Let's find the limits here. Limit as x goes to negative infinity of 1 over 2 e to 2 minus e to the negative x is going to be 1 over, and then e to the negative x, as I go off to the left here, goes off to positive infinity. So that's going to be 2 minus infinity is going to be 1 over negative infinity is going to be 0 coming from the bottom. Okay, so on my graph here, on the left-hand side, I come at 0 from the bottom. And then on my right-hand side, limit as x goes to infinity of 1 over 2 minus e to the negative x. And I showed you that e to the negative x has a horizontal asymptote over here on the right-hand side of 0. So this is going to be 1 over 2 minus 0 is 1/2. So on the right-hand side over here, and we come at 2/2 from the, or 1/2 from the, this is getting close to 0 from the top, a number slightly bigger than 0. So we're getting close to 2 from the bottom. So that's a number slightly smaller than 2, which makes this slightly bigger than 1/2. So we're getting close to this from the top, and that's up here. And my y-intercept we said was at 0, 1. And that matches that I'm coming from the top. And then I have negative ln of 2 somewhere over here for x equals, because that's bigger than negative 1/2, but smaller than negative 1. Or I'm sorry, smaller than -1/2 and bigger than -1. I was thinking absolute values just a second ago, but I should, and it should look something kind of like this. There's no x-intercepts. There's that y-intercept. There's no minimum value. It's just always decreasing here. There's no, and I could use my first derivative test to prove that. There's no concavity here. This is always, or no change in concavity other than at the vertical asymptote. This is always concave down. This is always concave up. And I could use my second derivative test to prove that the asymptote is the only thing that's forcing those changes in direction. So there's my sketch, and I've gone ahead and put it in my y equals here. And there's the graph for you. It certainly does look like that. So that's it for this video. And we will come back next time and start to talk about some application problems, some word problems from this section, where we're going to use derivatives of exponential functions to do some things that we've been talking about to maximize, minimize, and optimize, and so on. So there we go. See you for the next video.